Hello my dear students, welcome to my channel Fluid Mechanics Lecture Series. I am your SumamMiss. My channel name that is also SumamMiss. So please watch my videos, comment. I am just awaiting your comments. Today we are going to discuss about sensitive manometers. First one what we are going to discuss is single column manometer. Single column manometer is the modified form of YouTube manometer in order to simplify the measurement. Because of this large cross-section area, the fluctuation here is very less. So among the two limbs, left limb is enlarged. So this portion we are calling as basin. So comparing the cross-sectional area of this right and left limb, the area here is about 100 times more than that of the area here. That is why whenever this manometer is connected to measure the pressure, the fluctuation in the liquid is very small in the basin compared to the fluctuation in the right limb. Hence, 10 cm movement in the right limb can create only 0.1 cm upward movement in the basin. As the volume moved into basin as area of this right limb multiplied with 10 cm. So the corresponding rise in the basin is A into 10 divided by 100 times area, that is equal to 0.1 centimeter. So that is why whenever this manometer is connected to a point to measure the pressure, the fluctuation in the liquid is very small in the basin compared to the fluctuation in the right limb. If you want to measure the pressure by a single column manometer, we can directly measure this column H in this right limb. So this is the advantage of this single column manometer compared to the ordinary YouTube manometer. So in the single column manometer, we need to note the reading in the narrow limb or in the right limb only. So hence we can neglect the fluctuation in the basin. Since we are not taking any reading from the left limb, it need not be made transparent. Normally it is made of iron. So in order to increase the accuracy, we can keep this limb vertical or inclined. Next is inclined tube manometer. So if you want to measure very low pressure and if you are keeping this left limb vertical, the fluctuation here is very less. In order to increase the length of the fluctuation, we can keep this right limb inclined. So you can see a significant increase in the length to be measured for a given head. So that means the least count can be increased, hence better accuracy can be achieved. So with this modification, the distance moved by the liquid in the right limb is more, hence is more sensitive. So the vertical height of this manometric liquid is given by H equal to L sin theta. Theta is the angle of inclination. So the measurement of pressure can be done accurately even if the pressure is very less. So that is the advantage of inclined tube manometer. Another type of manometer is micromanometer. So if you want to measure difference in pressure very accurately and the difference is very small, then we can use this micromanometer. In micromanometer, right limb and left limb both are enlarged. So this is called basin and two manometric liquids are used. Lower portion is filled with heavier liquid compared to the upper portion. So here in the lower portion, specific gravity of manometric liquid high compared to the upper portion. So for very accurate measurement of pressure differences, one can use this micromanometer. A simple type of micromanometer is a YouTube manometer in which two transparent reservoirs of wider cross sections are provided at the top of the both limbs. So here capital A represents the area of the basin and lowercase a represents the area of the glass tube. So the fluctuation in the basin is connected with the fluctuation in the limb by the equation A into delta Z equal to A into H by 2, or delta Z can be written as delta Z equal to A by A into H by 2. 2 points in the same elevation in a continuous fluid at rest are at the same pressure. So this is the result of Pascal's law. If you are equating the pressure head above this horizontal plane in both limbs, so it is Pa by rho g plus Z1 plus delta Z into specific gravity of the fluid in A plus Z2 minus delta Z plus H by 2 into specific gravity of this manometric liquid, that is equal to Pb by rho g plus Z1 minus delta Z into S3 plus Z2 plus delta Z minus H by 2 into S2 plus H into S1. So if you are simplifying this expression as Pa by rho g minus Pb by rho g, then this is the expression. Now you replace this delta Z by means of delta Z equal to A by A into H by 2, and simplifying this expression, the final expression is Pa by rho g minus Pb by rho g equal to H into S1 minus S2 into H minus A by A into H minus A by A into H into S3. For a particular manometer, all parameters in this equation except H are constant. So therefore, by measuring the height difference in the heavier manometric liquid, the pressure difference can be calculated. So that is of with higher accuracy. Manometers are not generally used for the measurement of very high pressure. So in order to measure very high pressure, normally you are using mechanical gauge. The Bourdon gauge is one of the mechanical gauge. It consists of a tube of elliptical cross section. One end is closed and freely movable, and other end is connected to the fluid whose pressure is to be measured. Fluid with pressure that is enters to the tube, this elliptical cross section is changed into circular. So this elastic deformation is transferred in amplified form by using a pinion sector arrangement to a pointer that is moving over a graduated square. This Bourdon gauge can be used to measure high pressure as well as the low pressure like negative or vacuum pressure. Then we can call this gauge as compound gauge. Another mechanical gauge is different gauge that will also work similar to the principle of Bourdon gauge. Now the session comes to an end. Please watch my videos and comment. Your comments are highly valuable to me. For the time being, it is enough. Thank you.